Today we'll discuss about finding a maximum contiguous subarray. Um, so the very first thought that I got into my mind is let's have two pointers here as start and end. Start will be here and keep moving the end and calculate the every possible subarray sum. So for this -2 and then it starts with the -2 and then -1 and then -4, likewise till this part, and take the maximum of that. For suppose the maximum that we got uh, during this sum is 5, then this will 5, and then again move first and second index to the second index, first and last index to the second index, and again repeat the same process, and you will finally get one maximum of that. For suppose that is 6, and again you will do this and you will get some other maximum for suppose 7, and again you will do this with the 4 and do this the -1, do the same with the 2, likewise you will do the same with the 4. So how we are doing it? For every element we are comparing it with the every other n-1 elements. So the time complexity would be, I mean, this element requires n-1 comparisons, and this element requires n-2 comparisons, and so on. This element requires one comparison. So this would be sum of n-1 natural numbers, that is nothing but n into n-1 by 2 n square, which leads to the O of n square. This, so the very first thought that I got is the solution. But then when I search online, I found one algorithm called Cadenas algorithm, I guess. Uh, so in that way we can solve this in linear time. I'm going to explain that. Mm, so the approach for this is we need to maintain few variables to keep track of the values. Uh, so I'm just explain the algorithm first. What is the maximum till the position first one, the 0? That is no element before that, so that would be -2. So when you consider the next index, will this will the sum of will the sum from the starting of the array to till this index make a greater sum, or this element itself makes the greater sum? So to explain that, so the comparison would go like this. Two values will be there. One, this will be 1, and the sum that we compare with to decide the maximum till that point is the sum. So if I add the previous sum and previous point, if I add the max sum till the previous point with that element and compare that with the element, eh, if that element is maximum, then we will reset the starting of the subarray. So that means -2 plus 1 is -1. So the comparison would be -1 and 1. So will this make maximum, or this element itself makes the maximum? The element itself makes the maximum. So we are resetting the starting index of the or starting index of the subarray which forms the maximum sum at the end. So this would be 1. This is the maximum till this point. And then consider this index now, minus 3. So again the comparison would go like this. This is minus 3, and if I add 1 and minus 3, that would be minus 2. Which is making the maximum? Is the minus 2 or minus 3? Obviously minus 2 is the maximum. That means we should not reset the starting of the index, but we need to keep continue it, because still if by adding the previous maximum to this particular element is making the maximum than that element. So the max till this point would be minus 2. And consider this index 4. Now again, what is the comparison? 4 and minus 2 plus 4 is 2. Minus 2 and 4, which is maximum, 4 or 2? 4 is the maximum. That means the sum till that point is of no use. If we add that to this particular new element, we are decreasing the sum, we are not increasing the sum, so we will reset it. So maximum till would be 4. And then consider minus 1. Minus 1 will be the element that needs to be compared with what? 4 plus minus 1. That would be 3. So is minus 1 greater than the 3? No. So we need to continue the sum. The maximum till date will be 3. And then 2. Again the comparison starts with the 2. Comparison starts with the 2 with what? 2 plus 3, that is 5. So it's still increasing the maximum but not the decreasing, so we still should need to continue, and the sum will be 5. And then next element is 1. We need to compare this one with what? 6. Which is greater? 6 is greater, so we need to consider the previous sum, so this will be 6. And then minus 5. We need to compare this minus 5 with what? 6 minus 5, that is 1, which is maximum. Still 1 is making the maximum, so we need to continue comparing it, but the current sum will be 1. And then and then 4. The comparison will go with the 4. Compare with 1 plus 4, that is 5, which is making the maximum. 5 is so this will be 5. So we keep on doing this till the end. But if we observe this pattern, we are just repeating the things by considering the new elements in an array. The maximum sum will be 6. How we formed? From this place to this place. And we actually can keep track of the start and end index of this particular subarray as well in the code. So where, I mean, we can have few conditions where we need to set the start and where we need to stop the end index, that we can handle in the code. So in that way we actually can keep track of start and end index of the subarray, which making the maximum sum. So we will code this out now.